you get this molecule there, you get that product. Question is how to make that from here to there. We're adding the alkyl chain, right? We're adding alkyl chain to the benzene. So you kind of are scrolling through the what reaction do I know to put an alkyl chain to the benzene. And if you study the books and then materials, then some of you may think, oh, there's a Friedel-Crafts alkylation reaction, right? It's an alkyl chain, so Friedel-Crafts and alkylation reaction should be able to do it. For that, you got that part having a chlorine there, and then you're using aluminum chloride. So we are hoping the aluminum chloride take this chlorine away, making that the carbocation right there, the benzene makes an attack, so we get the product. So that is basically many of you who put as an answer. And then I'm going to point out that no, that's not going to work. Why that's not going to work is that chlorine next to the oxygen, I mean, the carbon that bearing the oxygen having a chlorine there. This is not very stable reagent. They're going to be decomposed right away. So you cannot make the reagents. So that's the reason. We kind of discussed a similar thing before. So if you know why it doesn't go, then you can have to go back and read on the material is it. But anyway, so this doesn't go because oxygen lone pairs comes in, they get ketone, and that's going to be popped out. So it's not stable. So if we cannot make this one, no, we still can make it. We just have to make it out of it. So how are we going to make it? You may need to think about some strategies. Sometimes it's not easy to think about going this way. Sometimes it's easier to walk backward. That's something for the retrospective analysis. You are analyzing the situation from the product. This is what you need to make it. Water can intermediate right before you finish up the synthesis. If you have that as an alcohol, then adding a methyl groups there is something that can be done. You probably know what to do. I'll show you later. But that can be done. The question is then how are we going to make this one? You get an alcohol there, right? But some of you remember that alcohol may come from ketone. So if you have a ketone there, then you can reduce that to human alcohol. So now, how are we going to make this one from there? It's just an acylation reaction, right? So instead of the Friedel-Crafts alkylation reaction, you should have thought about using Friedel-Crafts acylation reactions. That can be done easily by using this acetyl chloride, aluminum chloride. That's going to make the sodium ion basic reaction there. You get the ketone forms. Then this reduction is simple because you can use it as a sodium hydride. If you like, you can use a lithium aluminum hydride. The common hydride reagents can reduce that. Now you need to put the methyl groups to the alkyl chain. That I suggest that you take these protons off by using some kind of base. I say the sodium hydride is a base to use. Then we'll take the phenoxide there. Then you have an alkyl halide as the two reactions. Then you can make the product. So there is a way. It's not just the easiest route that may appear to you from the structures. This, if you choose that one, try to find the most simplest way to get there, then you'll find reality. So chemistry is a physical science that actually takes place. You cannot forget about the property of the molecule.